So today we're going to be taking a peek at section 1-4. Okay, and this section is about integers and absolute value. Okay, so when we think about integers, what we're actually talking about is the set of all integers, which is formally indicated by the letter Z. It's usually a fancy Z. For brevity's sake, we're not going to talk about that yet. Integers include all positive natural numbers, their opposites, and zero, Z, since zero is not positive, but it's still considered a natural number. So these are what integers are. So it's important to take note about that. It's important. So let's look at a few examples. Let's say we have 2, -3, 4, 4/5, 100, -6.5, and 0. Now, from this list, which of these numbers can classify as integers? Well, when we look at this, we can say that, well, since integers are positive natural numbers, can include that 2 is an integer, and 4 is an integer, and 100 is an integer. These are all positive. And they're natural numbers, which means a simple way of thinking about natural numbers is that if it's a number they use to count with, then it's natural number, including 0, because if you technically, when you're starting, the first number you start to count with is 0, even though you might not be taught that all the time. So since these are positive natural numbers, then these are integers. Now, how about -3? -3 is an integer because it's the opposite of 3. And so if it's the opposite of 3, which is a natural number, then it is an integer because it includes their opposites. Now, the last natural number on this list would be 0, because as explained by definition, the integers include 0, which is not positive, which not would be this symbol, not positive or negative, not positive. So how about these two right here? These two, the two remaining ones, these are not integers. These are not, because 4/5 and -6.5 are not. They're not natural numbers. They're not because they're not. You don't use them to count. -6.5 opposite of that would be 6.5. You don't go, when you count, you don't do 1, 2, 3, 4, 5, 6, 6.5. You just go to 7. Same thing with 4/5. You wouldn't go from 0 to 4/5, then to 1. You just go 0, 1. So these are not natural numbers. So therefore, or the opposite of 1. So therefore these are not integers. So with this terminology in mind, we just learn how to work with these integers and how to represent them. Let's say if we wanted to talk about, what if we wanted to describe something like you earn $100 from a sale. Now, what integer can you use to represent this? Well, you could see, the information we're given, we know that $100 is how much money you're given for it, and this is an increase. This is because it says you earn. If you earn something, then you know that you're accumulating wealth. So you're not losing money, but you're making money. So there's two ways to write this. You can either write just plain 100, or you could also write plus 100 to represent that it's an increase. So either one's acceptable because it's commonly known if you don't put a positive sign in front of a number, it's just positive by assumption. So when we look at this now, let's look at a different example. Let's say something like so the last one was you earn $100 from a sale. So this time we should try, what if we said that a diver descends, let's say, 200 feet below sea level. 200. So there's some indications here that represent the number. So descends means a negative relationship, and we also know the number we have here is 200 feet, and it says below sea level. So what we can tell from this is that this is not going to be positive, because if it's below sea level and it's descending, you're not going higher up in elevation. So an integer that could represent this is negative 200, negative, and then you can also add feet if you wanted to. But if you're just using a plain integer, then this right here would be the correct way to express it, negative 200. So this kind of relationship explained, we could try talking about another application of integers. Now, by now, you should know that something like this, if you are subtracting by a negative number, it's just the same thing as adding. So like 2 minus negative 3 would actually equal 5, because these negatives cancel out and it'll just be 2 plus 3. However, if we had 2 plus negative 3, that's the same thing as 2 minus 3, 2, which would equal negative 1. Negative. Because when it comes to if we were adding a negative number, only the positive cancels out. See, only positives cancel out. Like since the negatives have a negative, a positive, all this cancels out right here. But right here, there's already a positive number, so that just cancels out. Okay, hopefully you understand that relationship. Same thing if it was like this, you're still subtracting, because the positive will cancel out right here. Positive. So that's just some basic relationships. Now, something more complicated, rather elaborate concept is something called absolute value. Absolute. So, absolute value, if you want to be a formal definition of absolute value, is that it represents the distance, between a given number and 0. So let's look at this a little visually. Let's say we have a number line, okay? And this number line goes from, let's just say that this point right here is -5. So let's just make some increments here, just distinguish real quick. So we'll be just going by ones, trying to give you like a more rather simplistic approach to absolute value before we dive into the more theoretical stuff here. So we have this number line going from -5 to 3. Now, when the 0 is right over here, you see? So 0 is right here, right? Then what if we want to find? Let's say we want to find the absolute value of -5. So the symbol that represents absolute value are just these straight bars that the number is encapsulated within. So that is read as absolute value of -5, because you notice that those bars right there, that can also be called mid segments. So with this information in mind, let's try to find the absolute value of -5. So since we're going to use this definition of distance. So what's the distance between -5 and 0 on the number line? Well, we can count it most basically if we want to. Like, if you just count like this, that's 1, 2, 3, 4, 5. So if you just if you just count the distance in between each number, you're just gonna add 1 each time. So we notice here that the distance between -5 and 0 is actually 5, because the distance between the two values is just 5. That's how far apart they are from each other. So therefore, we can say the absolute value of -5 is 5. And if you notice this relationship, absolute value is always positive. And the reason for that is that there's no such thing as negative distance. Like, let's just say if we had like a car driving to a certain destination, it's obviously going to travel a certain amount of kilometers, and if you don't, and it's not like it's going to go negative, like it's going to say, oh, you traveled -300 kilometers. That doesn't make sense. Distance is always positive. Distance, it's a geometric relationship. In geometry, negative numbers are seldom used, so it's always positive, absolute value. And a trick with it, usually, if we're going to express this more algebraically, the absolute value of a number, or x, we could say, is always going to equal x itself. And the absolute value of -x is going to equal x itself. So it's always going to equal the positive variant of the variable. So let's just apply this real quick. So let's see if you can do this on your own real quick. Pause the video. What would be the absolute value of 4? And also, what would be the absolute value of 2? So I'm assuming you try it a little bit. The absolute value of 4 is 4. And the absolute value of 2 is 2. It stays the same because the absolute value of a positive number x is always going to equal the x itself. So the absolute value of 4 is going to be 4, and the absolute value of 2 is going to be 2. Now how about, let's try something a little different. The absolute value of -6 and the absolute value of -10. Let's see if you can try to figure that out. Okay, so let's see if you manage to get this correct. The absolute value of -6 is 6, and the absolute value of -10 is 10. And the reason for that is because if you have a negative number, it's always going to be the opposite, the absolute value. So if there's a negative number, you're going to get the positive variant of it. And then if you already have a positive, the absolute value of a positive number, it's just going to remain in that. It's just going to stay that number. It's going to stay. So that's the relationship. It's always positive. So if it's if the absolute value of a positive number or any integer, it's going to be the same as the integer itself. If the integer is negative, then it's going to be then its absolute value is going to be the positive variance or the opposite. So it'll be a good idea to take that into consideration. Maybe take a note about it. So let's look at some evaluations. Let's look at some What if we have something like the absolute value of 3 minus negative 4? 3 minus. This one's a little bit more complicated. Well, remember what I said earlier, that if there's two negatives, then they're going to cancel out. Okay? So what you're left with is 3 plus 4. Because these negatives cancel out, and you're just going to add 3 and 4 together. So 3 plus 4, absolute value of 3 plus 4 equals absolute value of 7. And then from there, absolute value of 7 is just going to be 7 because the absolute value of a positive integer is going to be the integer itself. Okay, now let's try something a little different. How about the absolute value of negative 5 plus negative 2? Okay. Now remember, the positive, in this case, the positive is going to cancel out. And then what we're left with is the absolute value of negative 5 minus 2. Which is negative 5 minus 2's absolute value is negative 7. What's the absolute value of negative 7? 7. Which is going to equal 7. Because the reason being is because the absolute value of a negative integer is the opposite of it. So it's positive opposite. So it's going to be the absolute value of negative 7 is 7. So hopefully you understand that relationship there. And how to cancel out different negatives and positives depending on the context. So once you get that down, we can try some more algebraic representations. We can try some more. Let me just fix this note real quick. Plus positive. So when we get this, my apologies. If we just have we're assuming that x is positive. So that was where I was going there. Okay, so now what we can talk about is, what if we had something like this? If we had the absolute value of x minus 2 and x equals, let's just say, 0. So in the last section, we learned how to evaluate these expressions. So we just replace x with 0, we substitute. 0 minus 2 is negative 2, so the absolute value of negative 2 is 2, because the absolute value of a negative integer is its positive opposite, so it's going to be 2. So that's a way to evaluate it. Now, hopefully you can understand how to do that by now. Now, maybe that's something a little more abstract. How about if we had the absolute value of x plus y? So we have two variables. Now, and what if we say that let's just say if x is positive and y is also positive. So what would the absolute value be then? If both of these variables are positive? Well, we can't, since these are unknown values, we can't exactly determine what the absolute value is. But from this information, if we say the absolute value of these two numbers is, let's just say z, then we know that it's going to be z is going to be a positive number as well, and this will and if we just put that positive number if we feel like it, but this would be the same if we had something like if we had x minus y and both numbers are still positive, then we can still imply that we do not know if it's positive or negative. So you can say in this situation, this z might not always be the same. So we can say the answer to absolute value of x minus y can be the absolute value. It can be when we evaluate in between, it can be positive or negative, but the answer itself is going to remain positive because the absolute value is always positive since there's distance. Okay. Now, with this in mind, if we were to go back to this diver question, if we were to ask something else, like how many feet did the diver actually travel? This is a different context, because it's asking how many feet did the driver travel. So it's asking you. It's not asking you how to represent that, how to represent the below sea level thing. And instead, it's asking how many feet did the driver travel. So if we're that, then traveling implies distance. So if we were to describe it in terms of distance, we know it's actually 200 feet is how many feet the diver traveled, not negative 200. Distance is not negative distance. So hopefully you can understand now exactly how you can put these integers and absolute value into a logical context, and that no matter what kind of variables we have, like if we had a crazy expression like x minus y plus z plus a squared or minus b squared or something, it may seem crazy at first, but we are always going to know that no matter what these variables are evaluated at, we know that let's change this real quick. We know that it's going to be that this no matter how these are evaluated, it's going to be a positive number. It's going to be a positive integer plus no matter what you get, because distance, absolute value represents distance, and distances can never be negative. That's one of the main points that you need to understand from this lecture. So, with this in mind, you should be able to utilize integers and absolute value in your homework assignment for 1-4, and you should be just fine as if you read the textbook as well. So, and that concludes this video.